Okay, so I'm going to make a brief little video overview of the Unit 1. Um, this PowerPoint is also posted in our course. So we had some readings this week that you had to do, and they will be on your quiz, which is due Friday, tomorrow. The first reading you had was 1.02 Chemistry and Society. And we focused on that chemistry is the study of matter, defined as anything that has mass and takes up space. There are 5 specialty areas within the branch of chemistry, and they are inorganic chemistry, organic chemistry, biochemistry, physical chemistry, and chemistry and analytical chemistry. The next section you had was 1.03 lab safety, and this is where we did the discussion assignment that was due on Wednesday. Common safety procedures that we look for in the lab or even in the at-home environment is just making sure you're following all instructions, dress appropriately, do not taste chemicals, learn where the safety equipment is kept, never point a test tube being heated toward you or another person, and leave your lab station neat and clean. We did go over a few other ones in class. This is more of a review for you guys, but I just wanted to touch base on each reading that you had assigned. The next reading that you had was 1.10 Matter and Energy. And as we discussed on that other slide at the beginning, matter is anything that has mass and takes up space. It's made of atoms that are too small for us to see. There are 3 common states of matter, and most of you guys know about this already. This is more of a review also. We have solids, liquids, and gases. And the main differences between those 3 are that solids have a defined shape, volume, mass. The particles are typically close together, so some examples of solids, we could use an example of an ice cube. Liquids do not have a definite shape. They do have a definite volume, mass. The particles are sort of close together, but not as close together as a solid. Example would be water. And then you have gas. Does not have a definite shape, does not have a definite volume, but it does have a definite mass, and the particles are spread far apart in the container. An example of this could be when water evaporates. You could think about clouds, etc. Matter can change states from a solid to a liquid to a gas, vice versa, and these state changes involve adding or absorbing energy. For example, adding heat or removing heat. Now, with matter, we can have, there's different ways it can change, and the 2 main ways are physical changes and chemical changes. Here are some examples, some common examples of physical changes. Melting ice, chopping wood, shredding paper. It does not change the identity of the object. So even if the ice melts into water, it's still water. Chemical changes are a little different. These are where new products are formed. Burning wood, mixing vinegar and baking soda as a chemical reaction, fireworks, and there are many more. Rusting. We looked at a few chemical changes in the lab that we did for 1.13. All right, so moving on to 1.11 was the next reading that you had, pure substances. So all matter is made up of mixtures and pure substances. And here's a little chart you can look at that sort of organizes it for you. Mixtures are a physical blend of 2 or more substances. So most of the time with a mixture, you can actually see the particles there. For example, like in this salad dressing, you can see the parts that make up the mixture. And they can be separated. Whereas the pure substance is uniform in its composition, and you cannot see any differences because it is pure. It's made of only one thing. And typically we have these as either pure elements or pure compounds. And here is another little diagram you can check out with some examples. So looking at elements and compounds, so the differences between them. A compound is a substance that contains 2 or more elements combined in a fixed proportion. we'll look at some examples of compounds in a moment. Whereas element is the simplest form of matter that has unique properties and is composed of only one kind of atom. And this is what makes up our periodic table. Every element on the periodic table is a pure substance. And here are some examples: chlorine, helium, carbon. And when we get to using the periodic table more next week, you'll see that there are many, many elements that make up our universe. So here's an example showing oxygen gas and ozone, which is O2 and O3. But since they're all still just composed of oxygen, they are pure and they are elements, not compounds, because if it was a compound, it would be combined with another element, chemically combined. We all know what water is, so a common example of a compound is water. Water has 2 atoms of hydrogen and 1 atom of oxygen chemically combined together. And because of this, there are 3 total atoms in the compound. So finding the total number of atoms in any compound it's pretty simple. It's done by just counting the total atoms in the elements in the compound. So in this specific compound right here, we can see that there's 1 sodium, there are 2 carbons, 3 hydrogens, and 2 oxygens, and we find that by looking at the subscripts of each one, and there's a total of 8 atoms in this compound. The next reading you had was 1.12 mixtures, and these can be what we call either heterogeneous or homogeneous. Heterogeneous mixtures would be examples like salad, ice cubes in a drink, and you can just see the defined parts, okay? Whereas a homogeneous mixture, it would be hard to see the parts. So like coffee, for example, there are different substances there, but they are mixed together and they look as one. And the last reading that you had was 1.13 properties of substances. And matter has both physical and chemical properties, and we looked at some of these also in the 1.13 lab that we did in class together. So, some physical properties would be density, melting point, freezing point, boiling point. There are many, many more. Chemical properties, we looked at corrosion, flammability, and things like that when we did the lab. More specifically, physical properties are a characteristic of substance that you can see without changing the nature, without changing it. So it's only going to change the way it looks per se, but it's still the same substance. And one common physical property, and this also does pop up in your Unit 1 week quiz, is density. And for density, it is mass divided by volume for your formula. So if you do 20 divided by 5, you get 4, and that would be your density for that problem. And then lastly, chemical properties do change the substance, typically making a new substance. And some examples of those are here on the slide: toxicity, heat of combustion, flammability, and we looked at this a little bit with that lab, and we're going to be going more in depth to this as the weeks move on. So that's a brief overview. Make sure that you've gone through and done all the reading assignments before you take the quiz. They're all in the content section of our course. I did post a video that goes over how to access the readings, and I hope that this helps, and let me know if you need anything.